All right, let's just get straight into it. Welcome to this comprehensive explainer. Today, we're basically grabbing our gear, adjusting our headlamps, and going on a massive archaeological dig. But look, we aren't looking for ancient pottery or dinosaur bones here. We're uncovering the hidden clues buried deep inside the Cambridge Information Technology and Computer Science exams. Specifically, we're targeting one of the most notoriously tricky areas of the entire syllabus, Section 4.1, Writing Algorithms Using Pseudocode. And we're zeroing in on the absolute fundamentals, the input, read, write, and print commands. Now, I know what you might be thinking. You're probably sitting there saying, input and print? Seriously? That's basic stuff. But as literally any seasoned Cambridge examiner will tell you, the basics are exactly where top-tier candidates stumble and lose critical, easy marks. Whether you're studying syllabus 0417, 0478, 2010, 9618, or our main focus for today, the AS and A-Level 9626, the strategy we're about to unearth applies right across the board. We're going to treat every single exam question like a precious artifact. Layer by layer, we'll brush away the confusion, decode the examiner's true intentions, and reveal the perfect high-scoring answer.
So the big question, the absolutely crucial point we need to address is this. Why do genuinely smart, well-prepared students lose easy marks on something as seemingly straightforward as 4.1, writing algorithms using pseudocode? I mean, the commands input, read, write, and print, they're the lifeblood of any algorithm, right? They're literally how data enters the system and how information leaves it. Yet, when we look at examiner reports, they consistently show a massive drop-off in marks right here. Why? Well, it's because students struggle immensely with multi-stage analysis and securing what we call method marks. A student will see a prompt to ask a user for their name, and they'll just write input name and move on. But in a multi-stage Cambridge scenario, that is just the tip of the iceberg. What about the prompt message? What about the data type? What about the overall format of the code? Examiners aren't just scanning your paper for a single keyword. They are looking for a highly systematic process. They want absolute proof that you understand the flow of data. Failing to grasp this multi-stage requirement is hands down the #1 reason candidates drop entire grades.
To actually master this, we need a rock-solid blueprint. So here's our agenda for today's session. We'll kick things off with the challenge. Then we'll move into the strategy reveal, undergo the transformation, jump into a fast-paced interactive workshop, and finally, we'll lock in your final blueprint. Let's get right into it.
Starting off with Act 1, the challenge. Because to figure out how to get it right, we first have to fully understand exactly how it goes wrong. Okay, I want you to meet Alex and Sam. These are two archetypical students we see sweating it out in the exam hall every single year. Imagine an exam question asks you to write an algorithm to input 50 student grades and output the average. Alex, who's the classic overpreparer, completely overloads the answer with raw facts. Alex is defining loops and arrays, going into way too much detail but with zero actual algorithmic analysis. It's just a textbook knowledge dump. Sam, on the other hand, is the rusher. Sam goes the complete opposite route, scribbling down read x, write x divided by 50, completely missing the formatting, the initialization, and, well, the loop itself. Both of these approaches totally fail to show the connected conceptual understanding that the 9626 syllabus explicitly demands. The examiner's basically left staring at either a massive, confusing essay or an incomplete, rushed fragment. And honestly, neither of these scores well at all. We actually dug really deep into the Cambridge Principal Examiner reports for Section 4.1 to figure out what's going on, and we extracted the top 3 fatal mistakes. Number 1, using the wrong approach for the context. This basically means blindly applying a generic input loop when the scenarios specifically ask for a single read from a sensor. You have to remember context is king here. Number 2, missing format and presentation. Pseudocode has very strict conventions. If you aren't using proper indentation, if you aren't using capital letters for command words like write or print, and if you're not using clear, sensible variable names, you are just bleeding marks for no reason. And number 3, non-specific answers. Look, if the question asks you to output a warning message for a high temperature reading, writing print error is completely non-specific. Writing print warning temperature exceeds 90 degrees is specific to the context. Failing to double-check your format or failing to provide that context-specific detail literally destroys your mark potential no matter how amazing your underlying logic might be.
Moving right along to Act 2, the strategy reveal. It is time to put on our expert archaeologist hats and decode exactly what the examiner is secretly begging you to do.
So, the assessment objectives. Think of these as the Rosetta Stone of Cambridge exams. You see, the exam board is targeting 3 very distinct cognitive domains. First up is knowledge and understanding. This is simply knowing that the read command takes in data. But honestly, that's only worth a tiny fraction of the marks. The next level up is application. This is where you actually use the read command in the real context of the problem. For instance, writing read student age. But the absolute holy grail, where the distinction grades actually live, that's analysis. This is where you connect multiple, shifting concepts together. It's writing an algorithm that uses an input command, stores that input securely in an array, compares it against a strict boundary condition, and then uses a print command to output a dynamically generated response. To truly conquer 9626 pseudocode, you must consciously transition your brain from basic knowledge retrieval to deep contextual application and analysis.
And how exactly do we structure that analysis, especially when a tricky question asks you to evaluate or explain an algorithm? Well, we use the PEAL framework: point, evidence, explanation, link. The absolute top students use this religiously. Your point is your initial punchy statement. For example, a while loop should be used with the input command. Your evidence is pulled straight from the scenario because the number of data entries is currently unknown. Your explanation justifies that choice. This ensures the program only processes valid data before finally printing the results. And your link ties it all beautifully back to the overarching system requirement. By using comparative connectives, words like whereas or therefore, you prove to the examiner that you aren't just guessing, you are making calculated, highly justified engineering decisions.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's jump into Act 3, the transformation. It's time to rewrite those deeply flawed approaches we saw earlier and reveal your ultimate safety net for the exam.
Here it is. This is your survival guide for tackling absolutely any pseudocode question. It's a standardized 5-step procedural framework. Step 1, deconstruct. You need to break that dense question paragraph down into distinct logical requirements. Step 2, extract. Pull out the exact variables, the specific data types, and any hidden conditions given in the text. Step 3, select. Choose your tools wisely. Are you using input or read here? Print or write? What type of loop makes sense? Step 4, execute. Write the logic out systematically, applying all those relevant principles with crystal clear working. And finally, Step 5, present. Format it beautifully, indent your loops, capitalize those keywords, check your spelling. If our friend Alex had used this system, the answer wouldn't have been a rambling essay, it would be a sleek, streamlined algorithm. If Sam had used this, the variables would have been extracted properly and the formatting would be flawless. Memorize this sequence, because it guarantees you won't miss a single requirement.
And this brings us to a massive, absolutely critical warning straight from the examiner reports. Even if your final answer is dead wrong, method marks can save you. You must show you're working. I literally cannot overstate the immense importance of the method mark strategy. Look, in Cambridge 9626, if you are asked to write a 10-line algorithm to input data, sort it, and print it, and you totally panic and mess up the sorting logic, you do not get a 0. Let me repeat that. You do not get a 0. If you correctly initialize the variables, boom, you get a mark. If you use the input command inside a correctly structured loop, you get marks. If you use the print command at the very end with a sensible output string, you get marks. Clear annotation, visibly showing your systematic process, and writing down partial algorithms even if you're stuck on the complex math is absolutely vital. Think of it like this. You are mining for method marks at every single step of the dig.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome back. Let's dive into Act 4, the interactive workshop. Because theory is great and all, but active application is where the marks are actually won.
Okay, here is your first challenge. We're going to dry run this complex pseudocode trace table. I want you to imagine a 60-second timer counting down right now. In a real exam, you are so often asked to manually trace an algorithm that uses read and write commands to populate a table exactly like this one. So, what is the core trend here? What actually happens to the variable right after the input command triggers the loop? 10 seconds in, you should be laser-focused on the initial states. 30 seconds in, you should be tracing the relationship between the input data and the conditional statement. By the time that imaginary 60 seconds is up, you must have extracted the hard evidence. The skill we're practicing here isn't just mindlessly reading numbers, it's interpreting the underlying algorithmic relationships and drawing a solid, evidence-based conclusion about what that print statement will ultimately output.
Now let's look at a quick Find the Flaw challenge. If a question asks you how to securely capture data, a highly flawed answer is simply writing use read command. Now, why is that flawed? Well, because it totally lacks the context we discussed earlier. Now look at the perfect answer on the other side. Use read command to input user age, checking reasonableness. This is exactly what the examiner commentary is begging for. It shows specific context. We aren't just blindly reading data, we are specifically reading the user age. And crucially, it adds the systematic solving element, checking reasonableness. In information technology, an input without some form of validation is just a disaster waiting to happen. You absolutely must demonstrate evaluating thinking by questioning assumptions. In this specific case, anticipating that the user might accidentally type a negative number for their age.
Let's move to our final workshop drill, speed writing. Here is a timeline for crafting a perfect, highly scored response in just 30 seconds flat using the deconstruct, solve, evaluate method. Imagine this. At 0 seconds, your pen hits the paper and you instantly identify the given information. What are the specific inputs? At 10 seconds, you solve systematically, breaking the logic down into discrete, manageable steps. At 20 seconds, you check for reasonableness. Did you format the print statement correctly? Did you remember to close your loops? And at 30 seconds, if it's an extended response question, you make your fully justified recommendation. This speed drill is amazing because it forces you to stop waffling like our friend Alex and stops you from rushing and missing steps like our friend Sam. It forces pure, unadulterated structure.
And that brings us perfectly to Act 5, the final blueprint. Let's take a breath and consolidate everything we've excavated today into one definitive, foolproof system. Here is your ultimate 3-rule blueprint to take into your exam. Rule 1. Command word decoding. I mean it. Never start writing until you know exactly what the command word requires. Write an algorithm strictly means use pseudocode with perfect formatting. Explain how means break out the Peel framework. Rule 2. Peel framework application. Whether you're justifying a choice of variable or explaining the function of a loop, make your point, provide evidence from the prompt, explain the logic, and link it back to the overarching system. Rule 3. The time management matrix. Complex input and print algorithms take real time to trace. Allocate your minutes strictly based on the marks available. Please, don't spend 15 minutes writing a perfectly formatted structure for a tiny 3-mark question, and definitely don't rush a massive 10-mark algorithm in 2 minutes. Follow this blueprint to ensure appropriate formats, correct terminology, and to maximize those beautiful method marks.
And I want to leave you with this number. The number 2 is incredibly crucial here. Students who consistently apply these specific critical analysis and procedural strategies, the ones who actually decode the questions, format their pseudocode properly, and actively hunt for every single method mark, they see an average improvement of 2 full-grade boundaries. That is literally the difference between a C and an A. That is the difference between struggling to remember textbook definitions and demonstrating the connected, conceptual mastery that Cambridge examiners absolutely love to reward. But remember, this kind of transformation only happens if you practice it consistently.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. And as you head back to your studying, ask yourself this one final question. In the high-pressure environment of the exam hall, will you be the student who leaves easy marks buried in the dust, or the one equipped with the exact blueprint to excavate every last point? Keep digging, and I'll see you in the next one.